Now, we've seen that biotransformation generally, we are talking about biochemical changes that convert lipophilic substances to hydrophilic ones so that they can easily be excreted from the body. Now, if you look at benzoic acid can be biotransformed so that it can easily be excreted from the body. And the pathways this can take so that it can be excreted from the body is one, conjugation with glycine. And you agree with me that conjugation, is it phase 1 reaction or phase 2 reaction? Phase 2 reaction, right? So conjugation with glycine. Now just look up, don't write, just look up. If you are drawing the structure of benzoic acid, first you draw your benzene ring. Then you put your acid functional group. Now I want to point out something. This is your benzoic acid, right? What if I remove this hydrogen and I put this? This is what? Benzoate, right? Good. So we'll be using benzoate because that is how most of these things exist when they enter biological system. But if they say write on the biotransformation of benzoic acid or benzoate, it's the same thing. You get that? Now, this is benzoate. The first thing that will happen is this benzoate will be activated. It will be activated by acetyl-CoA. So what will happen is ATP is there. CoA should come in. Now, if you look at this, if CoA is coming in, you have, let's use the full compound, acetyl-CoA. You have this. You agree with me that this is the same thing as this, right? If I don't want to write COO, I can put it this way. Now, if CoA is coming in, what will happen? What do we do? So what will you call this? So if you are doing this, the acetyl group is leaving, or you simply use your CoA only, since that is what you use. Now, in this case, this is benzoic what? Benzoic CoA. Now, benzoic CoA now can then undergo conjugation with glycine. Remember the structure of glycine. Glycine is an amino acid, right? This is the structure of glycine. Now we want to attach the whole of this with this. We want to attach that with this. Let me clean this so I can make it straight. Now, if you want to attach this with this, what will happen is the CoA will be going out. So if CoA is going out, you just attach this to this. Do you get that? So if the whole of this is going out, how do we attach this to this? It's just simply removing. Okay, let me increase it. So we'll be having this. Now CoA is going out. I will just attach this with this. But remember, how many hydrogen do we have here? 2, right? And nitrogen is supposed to have how many hydrogen? Nitrogen is supposed to have how many? 3, right? So if I'm to attach that, I'll have to remove one hydrogen. So what I'll be having is this NH-CH2 COOH. Did you see what happened there? I just removed, this is glycine, is it not? I just removed one hydrogen from glycine. Because nitrogen was supposed to have 3 bonds, 1, 2, 3. So if I still put NH2, then hydrogen is overloaded. Sorry, nitrogen is overloaded. Do you get that? So what was going out? CoA was going out, right? And what's the name of this now? Hippuric acid, right? Now, this hippuric acid is water soluble. It's very soluble, so it can be easily excreted by the kidney. This one was more lipophilic than this. Remember, biotransformation, we are looking at biochemical changes that take place in an organism, converting lipophilic substance to hydrophilic substance so that they can easily be excreted, right? So we've successfully converted this to a hydrophilic substance that can easily be excreted from the body. So this is one way benzoic acid or benzoates can be biotransformed, by conjugation with glycine. So we just conjugate it with glycine and we have this. But don't forget, the only thing we did here was first, the benzoate was first activated, right, by coash, is it not? To form what? Benzoic CoA. Now glycine comes in now. So glycine came in and displace the coash to form your hippuric acid, which is more water soluble. That's that. Any questions so far? All right, so we've seen that there are two main conjugation reactions benzoic acid can undergo during its biotransformation. And the first one we say is what? Conjugation with glycine, right? Now the second one is conjugation with what? Glucuronate. Now, if we already know the structure of our benzoate, right? These are benzoates, is it not? Now, benzoate, if it's undergoing glucuronidation, what will be the donor? UDP what? Glucuronate, right? And what are we interested in? Only the glucuronate, is it not? So what will be given up? UDP. And what will be the name of the enzyme catalyzing this process? UDP glucuronide transferase. And always note, as a cheat, this is always the point of attachment to anything you are conjugating in benzoic acid. Remember, when we start with glycine, we attach the benzene here. First it was activated, is it not? Now in this case, if glucuronate is coming in, what we do is this. Now to this we attach our glucuronate, but if you are attaching glucuronate to form a conjugate, what will be the name? Gluco what? Ronide, right? So what will you call this? Benzoyl glucuronide, right?